today I will begin with the introduction of the Multicore organization. So basically, um, multiple processor cores are arranged and then combined into a single physical processor using a multi-core architecture. It is to build a system that can handle more jobs concurrently and improving system performance in general. Basically, the typical application of this technology is in multi-core CPUs, which have two or more processing chips or cores operating concurrently as a single system, such as the mobile devices, desktops, laptops, workstations, and many more. The idea behind multi-core technology primarily focused on the potential for parallel computing, which involves combining two or more central processing units, CPU, into a single chip to increase the computer speed and efficiency. So, multi-core technology will help in difficult jobs and applications like video editing, 3D gaming, and encoding. Furthermore, it is also more efficient than multiple chips with single cores because it is faster than between chip communication. So, as you guys know, there are several companies that are making or planning to make multi-core chips. The company first is AMD, which released Opteron Enterprise Server Multicore first, then the Athlon 64 and Sempron desktop chips, and finally Dura mobile chips. And the second one is the most famous one. We all have this in our laptop. Not all, but nowadays most people using this. Um, so this is from the company of Intel. Intel is working on 16 multi-core chips project. Intel has developed energy-saving dynamic power coordination technology that when workload permits, the operating system tell one processing core to sleep or slow down while the other works. In 2002, Intel also introduced its hyper-threading technology. Basically, hyper-threading technology lets multi-threaded software threads execute in parallel on a single core. Thereby, it will be improve the performance and speed. Next is the IBM. IBM released the industry's first dual-core server chip, the Power 4 in 2001, and the last year it introduced the dual-core Power 5, which ran 4 times faster than its predecessors. And the last one, in 1999, Sun released the microprocessor architecture for Java computing dual-core multimedia desktop chips. But the MAJC multiprocessor architecture for Java computing never widely used, and since then they built the new one, Ultra Spark 4 dual-core server chips. So next, I'll be presenting about the organization block diagram of the multi-core organization. Basically, we can see there is core 1, core 2, core 3, and core 4. So there is involving the multi-core, so many core. The following step is on how the CPU will execute the instruction. So basically, as we know, the control unit obtains the instruction from the memory, the computer's memory. And then the control unit reads the instruction and extracts the meaning, then directs the vital or required data to transfer the memory to the arithmetic or logic unit. Instruction time is referred to as the first to the steps. So the arithmetic or logical instructions carried out by a loop. This is when the actual operation of data is performed. So the results of the operation are stored in the memory or in a register by a loop. Execution time is referred to the step 3 and the step 4. Okay, so basically all these 4 cores will follow these 4 steps. This means a lot of tasks can be done simultaneously or parallelly at the same time.
I'll be talking about Intel Core i5. According to Wikichip, Intel Core i5 was actually introduced back in 2009. It was actually intended for mainstream users, like normal users who use computer on a daily basis, other than using like heavy software or etc. It's just like people who use computer for normal purposes like words, etc. And it is actually a family of mid-range performance of 64-bit times 86 processors designed for laptops and desktops by Intel. For your information, Intel Core i5 was actually located between the low-end Intel Core i3 and also the high-end Intel Core i7. It is actually have much more better specification compared to i3, such as turbo boost technology and etc. And this is fun fact for your information. All of us think that actually Intel Core, the sequence of Intel Core launching is actually starting from Intel Core i3, followed by i5, i7, and i9. Actually, that is not the case. Intel Core i7 was introduced first in the Core family, in which it was introduced back in 2008, and followed by Intel Core i5, which is introduced on 2009, as I've mentioned before. And finally, Intel Core i3 was launched on 2010. And it was followed by Intel Core i5, which was i7, so i9, sorry, which was what we call launched back in 2017. So the sequence of launching was from i7, i5, i3, and finally i9. So that is for our Intel Core i5.
Assalamualaikum and hi everyone. I will present about advantages and disadvantages of multi-core processor. So the first advantage is its performance. On default, a multi-core processor allows more work to be done than a single core processor. The core present on an integrated chip are placed at a distance where high clock speeds are achieved. A high clock speed means a faster processor. Therefore, the signal do not need to travel far to reach its destination, plus it is persistent too. So the speeds are significantly higher than a separate processor. Second, its reliability. In multi-core processors, software is allocated on different cores. When a single software happens to undergo faults, it will not impact the other. So whenever there is a defect, it is restricted to a single core. Thus, multi-core processors are able to tolerate faults to a greater extent. Next, good software interaction. Even if there is software execute on different cores, it will still interact with one and another. A multi-core processor undergoes a process known as spatial and temporal isolation. This process makes sure that core threads are never delayed. After that, it can be multitasking. A multi-core processor can make an operating system run 2 or more tasks concurrently. Even it is possible to perform tasks of the same application simultaneously. For example, a Photoshop application can be used for 2 tasks simultaneously. And lastly, less power consumption. Performing multitasking essentially with a multi-core processor requires less amount of power. It is only the part of the processor will be working to generate heat, but eventually the power consumption is reduced, resulting in less battery usage. Next, it is about the disadvantage of multi-core processor. Firstly, the performance boosts are limited. Multiple processor in a processor package must share common system buses and processor caches. The more processor cores share a package, the more sharing must take place across common processor interface and resources. So for most situations, the performance benefits of having multiple core far outweighs the performance loss to such a sharing. Next, the power, heat, and clock restriction. A computer may not be able to drive a processor with many cores as hard as a processor with fewer cores or a single core processor. A modern processor core may contain over 500 million transistors, each and each transistor generates heat when it switches, and this heat increases as the clock speed increases. So when more cores are running, this heat can multiple and quickly exceed the cooling capability of the processor package. So this reduces the performance of all processor cores in the package. After that, the application speed. Although a multi-core processor is designed for multitasking, its speed is not significant enough. Each time when an application is processing, it tends to jump from one core to another. As a result, the cache gets populated, compensating for its speed. And then jitter. When the number of cores in the multi-core processor increase, it will cause more interference, leading to excessive jitters. As a result, your OS might potentially experience degrades in the performance of programs and frequent failures. And lastly, the software interference. A software interference that is caused due to the resource sharing can cause problems to spatial and temporal isolation. These resources include main memory, system bus, memory controller, and networks. So more cores essentially means that there are a high number of interference paths. It's almost impossible to analyze each and every interference path. Okay, next I will present about advantages and disadvantages of Intel Core i5. So one of the advantages of the Core i5 is that it is a mainstream processor designed for all-around computing requirement. Manufacturers such as Apple and Dell have featured numerous versions of this chip in their high-end computers and laptops. It means that it can handle day-to-day tasks such as web browsing, content consumption, and office productivity. Furthermore, it is capable of handling some tasks that require considerable resource to include average-level video editing and gaming. Secondly, its performance and flexible application. Depending on the specific model or variant, the processor sits in the mid-range to high-range computer usage spectrum. So it is between the Intel Core i5 is between i3 and i7. So users can choose from different variants based on their budgets and their personal or professional requirement. Intel Core i5 is essentially positioned as a mid-level and mainstream CPU that is engineered for graphic-intensive gaming, multitask business productivity application, and general to above average high-definition video and audio editing. And then disadvantages of Intel Core i5. Firstly, its performance limitation and applications. Of course, it will perform poorly when compared alongside Core i7 and Core i9. These processors have better hardware architecture and specifications because they are positioned in high-level and top-tier computers and use case scenarios. It's also important to highlight the fact that the Core i7 is marketed for high-level users, while the Core i9 is geared toward the enthusiast level users. So the Core i5 will not be able to address the specific resource intensive requirement of these users. Secondly, the intensive gaming and video editing. Remember that this processor, which is Intel Core i5, can still handle a considerable degree of video editing and gaming. But the newer generation could competitively accomplish the average needs of video editors and the requirement of some gaming titles. However, there is a limitation on how much it could perform these tasks. Is typically not ideal for accomplishing intensive game at higher frame rates as well as editing longer videos. Furthermore, it will be unsuitable for animation and graphic rendering. And lastly, a note on multitasking capabilities. And lastly, a note on multitasking capabilities. The core line of processors from Intel is different in the way they handle processing information. Typical variant of the Core i5 have few cores and support fewer simultaneous threads than the Core i7 and Core i9. So these variants are not as good as multitasking. A key disadvantage of the Core i5 is that it is not engineered and positioned for demanding work. It will not match the capabilities of current generations such as Core i7 and Core i9, so as well as equivalent processors from other manufacturers. So I think that's all from me. I will pass to the next presentation. So I think that's all from me. I will pass to the next presenter. And lastly, a note on multitasking capabilities. The core line of processors from Intel is different in the way they handle processing information. Typical variant of the Core i5 have few cores and support fewer simultaneous threads than the Core i7 and Core i9. So these variants are not as good as multitasking. A key disadvantage of the Core i5 is that it is not engineered and positioned for demanding work. It will not match the capabilities of current generations such as Core i7 and Core i9, so as well as equivalent processors from other manufacturers. So I think that's all from me. I will pass to the next presenter.
Assalamualaikum and hi, my name is Sumaina binti Muhammad Hai. My metric number is 202250 and I will be presenting about the performance of the multicore. So multicore processing can increase performance by running multiple applications simultaneously. The closer the cores to each other on an integrated chip enables shorter resource access latency and also higher the cache speed. However, the size of the performance increase depends on three subjects, which is the memory subsystem. And then the second one is inter-core communication, which is the communication between the core. And then the last one is the application parallelism. Actually, there are many factors that will affect the performance, but I will focus on these three factors. So the first one, and the memory wall arises for high frequency processes because the speed disparity between dynamic random access memory, DRAM, which is a modern kind of RAM, and CPU is so large that memory access might constitute a substantial application bottleneck. So bottleneck is a component that limits the potential of other hardware due to differences in the maximum capabilities of the two components, which also mean bottleneck occur when there are transmission between the two components from different sides. So when it comes to today's data-intensive or data-driven machine and deep learning applications, things get much worse. To summarize, the existing memory bottleneck can impair the machine's performance by slowing the transmission of data between the CPU and the RAM when it is used repeatedly. As a result of the longer processing times, computer processes become slower. And in other circumstances, where there is insufficient RAM or memory allocated for the current application, the memory subsystem might become a performance bottleneck, causing memory exchange to take longer. Even though multi-core system can help with memory, power, and other issues, they also can introduce new issues into the hardware architecture. The most significant architectural change is that when many cores are operating for the same application, they must interact with each other. In real life example, as we, a human being, we have to interact with other people in order to complete our daily activity. And however, improper inter-core communication can waste a lot of time in a multi-core processor, reducing the benefits of multi-core parallelism. The shared cache and memory system, which is now the most prevalent design for inter-core communication, is one option. However, such a design has a fundamental flaw to address, which is cache coherency. Because the application can run on numerous cores at the same time, they can generate data to write or read from the same memory address. Such read or write conflicts might result in a slew of issues that must be resolved. Many designs currently employ the OS critical session idea to avoid such conflicts and consequently cache coherency, but at the cost of ideal waiting cycles for other cores. And last but not least, application parallelism is another important feature that affects multi-core performance. This is understandable since a multi-core processor outperforms a single high-frequency process when a large fraction of parallelized execution codes can be retrieved from the application. So, for example, a simple machine learning model training application. When training a model with 4 splits of data on a quad-core processor, it can frequently simply parallelize all the computations and outperform a single core system with a similar frequency. When the program we are running is primarily sequential with a lot of data dependencies inside the instructions. On the other hand, multi-core processors can suffer from such dense data dependencies and can't match single-core processors in terms of speed. So that's all for the performance of multi-core. So to conclude today's presentation, the multi-core organization is one of the most important architectural elements in building a computer. There are a lot of companies that develop and use multi-core, such as AMD, Intel, IBM, and also Sun. These companies produce different types of multi-core chips by increasing the speed of each core. For example, in Intel, different types of multi-core chips are produced that are suitable for different types of user. If a user is a high-end developer or a gamer, it is suggested to use an up-to-date or recent multi-core processor such as, like we have now, Intel i7 or Intel i9. And if a person is a normal mainstream user, or for example, a student or an average user, Intel i5 or Intel i3 is sufficient for them. As discussed earlier, as mainstream users use Intel Core i5, there are a lot of advantages and also disadvantages that can be experienced by the users. Some issues and challenges are faced by Intel for the Intel Core i5. And the issues were handled well by the company as they updated their chip, by including those hyper-threading specifications in their newer generation chip. Thus, we can say that as the use of computers or technologies is increasing in this current generation, the company must take action in updating, introducing, and also innovating newer chips that suit the users as well as the market. We really hope that the company does research and develops new multi-core chips in the future, which can make the computer run in the instructions given by the user much faster and more efficient than current multi-core chips for future generation. And thank you.